Hi, this is Aaron Lewis from Franklin Maths. This video is on the distribution of the sample mean. It's the lesson just before hypothesis testing with the normal distribution. This is a fairly short video, but it is really important. Okay, so for this little section, I'm going to focus on beans. Okay, as we know, beans come in tins, and you'll see a label like this. So it'll say it's got 400 grams in it, and then you've got this funny little E symbol here. Now this symbol means that it's within a certain range of 400 there. Okay, not every tin will be exactly 400. Okay, what we're going to look at today is a little problem, and then we're going to extend it into hypothesis testing. So I'm going to talk about it now. I won't cover it in this video, but I will cover it in later videos. Okay, so it's just something to think about now. So if I pick 20 tins from the shelf, and then I weigh them, find the mass of them. Okay, and then I find the mean, and I find that the mean is 397 of those 20 tins. So does that mean that the manufacturer of the beans is underfilling the tins? Are they trying to make a little bit more profit out of us? Okay, so that's just something for us to think about, and more importantly, how could we test it? How could we go to manufacturer and go, hang on a minute, you're ripping everybody off here? That's what we're going to cover in the next video, but this is where it all starts. This is all looking at sort of samples. Okay, so hopefully that makes a bit of sense. At the minute, don't worry about if you can't answer this question. It's just something we're going to think about and work on. Okay, so if I was to look at the population of the tins of beans, so if I was to weigh every single tin that I could find, so imagine this is from the factory, you can see that I've got a mean of 400, and you could possibly see, look, I've used a standard deviation there of 3, and I've captured just about all the data. This isn't perfect. I've taken this from a brilliant little website which allowed me to manipulate some normal distributions. Okay, we'd expect a spike there, sorry, a spike, but the mode there of 400 and the mode, the mean, the median are all about the same on this normal distribution. Okay, but what about this? What about if I decided that I was going to collect samples from lots of different supermarkets? Okay, so I was going to visit all the different supermarkets in all different towns. Okay, and what I'm going to do is I'm going to get 10 tins and find the mean. Get 10 tins, find the mean. Get 10 tins, find the mean. Okay, I'm just an ass off there. Look, I'm going to use 10,000 samples. I'm going to visit 10,000 different stores. Don't worry about the real life interpretation of this. I found a website which will let me use 10,000 samples. So what's that going to look like? Okay, so I'm going to get 10,000 samples, find the mean, and then plot them. Okay, so I'm going to visit one store, 10 tins, find the mean. Keep doing that 10,000 times. Well, again, this is computer simulated, but this is what it'll look like. Okay, and then this time I'm plotting the means of 10 tins. So if you have a look, I've got a mean around 400, but it's not a spread. Okay, this is one of the trickiest topics that we do on this part of the course, but it's one I've also found quite difficult to explain, but hopefully I've done a bit of justice there in terms of what I'd be doing. So 10 tins, find the mean, 10 tins, find the mean, and plot them. Okay, now if I superimpose them, just a second, okay, what can you see? Anything particularly obvious? If you want to pause the video and jot those down, or if you want to talk to the video, although I can't hear you, feel free to do that. Let's have a look. So things you guys need to know for your exam. That the sample means gather around the same mean as the original data. What we're saying is the mean of the means is roughly the same, which we'd expect. Okay, and the sample means have a much smaller spread. Okay, which is what we'd expect as well. Okay, now I know some of you don't like transformations, but if you think about the transformation here, we're squashing it, or we're having a stretch in the x direction here. You think about what transformation that would be. Okay, so we can see that we've got roughly the same mean, but the standard deviation is smaller. Okay, it's been scaled down. Okay, so we've got a way of writing that. It'll look a bit weird at first, but once you work to the example, you go, yeah, I've got it, it's easier. Okay, so here it is. This is what you guys need to know. So if I've got a population or an original data set which is approximately normal, or is normally distributed, I've got mu and sigma squared. Then if I'm looking at now, this is the symbol for the sample means here. If I'm given sort of x bar with a little n on it, so n would be the size of the samples here. Just jot that down. So if I was gathering 20, batches of 20 beans, that would be a 20 down there. Okay, but this time, notice the change here. So we've got the same mean, which is what we said, but the variance here has changed. Now remember, if we were going to find the standard deviation of this, we'd need to square root both of those. Okay, so you'd have sigma squared over root n. Okay, or you can just square it over the whole thing. It doesn't really matter. Okay, so let me show you an example, and then you should be able to see exactly what's going on. Okay, so the mass of beans is normally distributed. Again, I'm sticking with the beans. Mean of 400 and a variance of 25 grams squared. Okay, and the first bit is to find the probability of that. So first thing we do is let x be the mass of a tin or randomly selected tin. I'm not going to get too stressed about that right now. Okay, so x tilde n, and what have we got? We've got 400 and 25. As I say, it's always good practice just to jot these down. So mu is 400 and sigma there, just lost my pen a second, and sigma there is 5. So I'm going to be grabbing the calculator for this. Should be easy enough to do. So probability 397. Now, compared to the other slides here, I've just changed the standard deviation. So don't just think it's going to be one standard deviation either way like it was earlier. This one I've changed it so slightly. Okay, so I'm just going to grab the calculator. Okay, so into stats, distribution, normal. We're not inversing here, we're calculating the probability. Our low value is 397. Upper value is 403. The sigma there was 5, and the mean was 400. And we've got 0.4515. So 0.4515. Okay, and then part B. Okay, now notice we've got a bit of a change going on here. So what I'm looking at now is to find the probability of the means being between those. Now, what we would expect initially is that the probability is going to be larger in this case. Okay, so we're going to try and find the probability that the mean, or the where the, if I was working sample size of 10s here, what is the probability of me getting a mean between those two there? As I said, it should be higher, because if you think about the graph, we know that they clustered more towards the mean. Okay, there was less spread. So first thing I'm going to do is write a couple of things down. So using up here, we know that mu stays roughly the same. Just if my pen decides to work, it'd be great. There we go. Mu is going to be equal to 400. And you need to be really, really careful here. So the new standard deviation here, and use SD for standard deviation. We can't really use sigma because sigma is already defined. That is going to be the square root of 25 over, now what's n here? Now n is going to be 10. Okay, I know there would be 5 over root 10, but it doesn't really matter. Okay, I'm going to leave it in exact form there. So all I'm going to do now is grab the calculator and then work it out. Okay, so here's the calculator, back in stats mode, distribution, normal, NCD. Most of the numbers are already written in for me. So sigma this time, we're going to have the square root of, open a bracket, 25 divided by 10. Mu is 400, and let's see what we get. So we get 0.9422. So 0.9422, and there is a massive difference between those two. And if I just go back a couple of slides, you can see, look, it's clustered a lot more around this mean. Obviously, it depends on what what the size of your samples are. Just skip forward a second. Okay. So explain the differences, and again, if you want to write what I've just said down, obviously it takes me a long time to write with this little pad I've got here. The difference is basically that when we're using samples, we're much more clustered around the mean. You'd expect to get a higher probability looking at the same range. Okay. Couple of other things you guys need to know on the next slide. So that's what we've looked at a minute ago. Easy peasy. Now the only thing I haven't mentioned here, in your worksheet that you've got, it asks you to find mu and sigma, and we know that if you need to find mu and sigma, you need to use the standard normal distribution. So when we're using the z-score, notice we've got an x bar this time, and the numerator, so the denominator here changes. Instead of sigma, it's sigma over root n. It's basically just the square root of that. Okay, so when you're using the questions in the worksheet, just watch out for using that. Mistakes will come in by people forgetting to square root. Okay, so that's all I've got on this video. It's quite short, quite to the point. Just make sure you read the question. They do like in the exam to flick between the sort of the original population or the original data set or the sample data set, so just watch out for that. Okay, so I'm going to ask you to complete questions 1 to 8. Certainly the first 2 should be fairly easy and quite easy to get along with. And they do get more difficult as they go down. Just watch out for those questions where you might need to involve something else. We've already seen in earlier worksheets that all of a sudden it changed to binomial. The biggest thing you guys are going to have to watch out for is finding mu and finding sigma, which involves using the standard normal distribution. Okay, so good luck with that. Any problems, let me know. Thank you for watching.